For a better overview, the life cycle of a plant is divided into 4 phases. The emphasis for the application of S7 Graph is the implementation phase. However, the characteristic properties of S7 Graph can also be perfectly used in the testing and commissioning phase, as well as in the later operating and maintenance phase. The Simatic software offers you the selection of several programming languages. The basic package contains the languages Ladder, FBD, and STL. The often used programming languages S7 SCL and S7 Graph are optional or available with Step-7 Professional. While programming with STL is hardware intimate, Ladder, FBD, and S7 Graph enable you to connect graphic elements with each other. S7 SCL is a programming language which, regarding syntax, follows the easier, manageable, high-level language Pascal. This selection of different languages enables you to use the most suitable one for the task, so their respective special features can be used to the best advantage. Basically, all automation tasks can be solved with the basic languages Ladder, FBD, and STL. Tasks such as data management algorithms can be solved particularly fast and clearly using the language elements provided in S7 SCL. In case of sequences, which can be divided into individual processing steps, the automation solution is considerably simplified using sequence chains in S7 Graph. All languages comply with the IEC 61131-3 standard. S7 Graph is discussed in the following and its application demonstrated by means of a specific automation task. Let us first take a look at the advantages of using the engineering tool S7 Graph. Apart from clarity, which results from graphical programming, S7 Graph can be easily learnt due to its intuitive programming and operation. S7 Graph is characterized by its low implementation times, as the code generation is less prone to errors. Also, users without special PLC knowledge, such as technological specialists planning and developing a plant, can implement their knowledge of technological process structures directly in a runnable PLC program using S7 Graph. S7 Graph achieves optimized program runtimes as only the active part of the program is being processed. The graphic programming interface reduces the search times for certain program sequences, hence reduces testing and commissioning costs. Nevertheless, there is still enough space for additionally increasing comprehensibility by means of code commenting. S7 Graph also provides a good basis for visualizing technical processes on an HMI system. This, together with the integrated process diagnostics functions, results in increased performance and reliability of your machine or plant. A number of applications within production and process technology show sequential structures. These sequence chains consist of individual steps that are processed successively, whereas sequential processing can be extended by branches. The following structures occur most frequently. During the linear sequence, the individual steps are processed successively. One step may contain different actions. The transition from one step to the next occurs via conditions that must be true. In the alternative branch, also depending on a condition, only one of several possible sequence branches is processed. The simultaneous branch enables almost simultaneous processing of different sequence branches, so that in this case, several steps can be processed as it were in parallel. The programming effort for realizing such technological tasks with sequential control is considerably less than with logic control. These advantages are provided to you by the engineering tool S7 Graph, as it depicts these technological sequence structures directly. In the following, we will look at a specific example in which we illustrate how the technological task of a drilling process is realized in an S7 Graph program. Our example has the following functionality. After pressing the button for starting the process, the cylinder slides the workpiece from the magazine to the drilling machine. The drill now drills a hole in the workpiece. During the drilling process, compressed air for chip removal is applied until the drill is back in the starting position. Then the slider moves back and the finished workpiece is ejected. If no more workpieces are left in the magazine, the indicator lights will indicate this, and the process be interrupted. The technological sequence structure results from the task described in this example. We now want to show you how simply the technological sequence structure can be realized as a PLC program using S7 Graph. We introduce the necessary activities from calling the editor to testing the complete sequence chain. The entire sequence program of this example is generated in a function block for which we select the language Graph in the Simatic Manager. The S7 Graph editor is started automatically by opening this block. First, we provide you with some characteristic elements of the S7 Graph editor. The toolbars contain symbols on which you can click to access the most frequently used menu commands. The work area is a window within S7 Graph in which one or several sequence chains can be displayed and processed. The sequence chains represent the program code. The Overview window contains 3 tabs whose contents help you with the orientation and processing of large sequence chains. The Details window at the bottom of the screen, with its various displays, supports you in generating the program. Processing a sequence chain always starts with a so-called initial step. The current step remains active until the switching condition or transition, which may be made up of ladder or FBD elements, is true. Then the next sequence step is processed. In addition to the program, extensive comments are possible, in the comment field as well as in every step directly. Let us now take a closer look at the program for our example. Let us consider the scene in which the workpiece is moved under the drill. The name of the sensors and actuators, here referred to as I and O, were filled in the symbol table of Step 7 beforehand, and are now used in our S7 Graph program. We start programming the sequence chain with the initial step S1, followed by the transition T1. As a first action, the workpiece is to be moved under the drill. To start this action, we created the following AND logic operation as transition T1. The magazine is to be filled with workpieces and the slider is in the starting position. A start signal, for example from a switch, activates the slider. If transition T1 is true, step S1 becomes inactive and step 2 active. There we set variable O1 for starting the slider, which causes it to slide the workpiece under the drill. If the slider reaches its end position with I2 equals true, it is stopped in the now active step S3. Let us now take a look at the drilling process as the next work step. Here we will meet a simultaneous branch at which both chain parts are processed as it were in parallel. Sensors I3 and I4 indicate the end positions of the cutter block. This information is used as transitions, in order to have the drill execute the vertical movement in steps S4 and S5. During the entire drilling process, compressed air for chip removal is to be applied to the workpiece. From the toolbars, we therefore insert a simultaneous branch in order to activate the compressed air parallel to the drilling process. Our sequence chain is terminated with the last process step, ejecting the workpiece. When the drill is back in the starting position, the slider also moves back to its original position. As soon as this has been reported by sensor I1, the ejector starts and ejects the workpiece before being pulled back to its original position by a spring. As soon as the slider reaches its basic position, the last transition T9 of the sequence chain becomes true. Basically, the sequence chain can now be terminated or a further sequence chain be started. In our example, the chain is processed cyclically, meaning another work operation starts in the first step S1 of the sequence chain. So far, we always assumed that the magazine was filled with workpieces. We now want to poll this status in the sequence program and react so that no action is to be started if the magazine is empty. This task requires a branch part to be processed as an alternative to the main chain. For the realization, S7 Graph provides us with the alternative branch. At the transitions T1 and T10, we check the sensor which monitors the magazine. If no workpieces are left in the magazine, transition T10 is true and an indicator light is switched on. Transition T11 ensures that step S1 of the sequence chain cannot be jumped to until there are workpieces in the magazine. A comparison between the sequence chain in S7 Graph and the technological sequence structure shows that their structures are equal. In the latter case, we can easily generate a runnable PLC program using S7 Graph. S7 Graph provides further support by means of functions not shown in our example, such as counter, times, arithmetics, jump commands, or also the option of calling other blocks, so that S7 Graph is also especially suitable for complex applications. How is the complete S7 Graph program integrated into the existing S7 project? After saving the sequence chain, a runnable function block is available in the block container of the Simatic Manager. For it to be applied within the S7 project, it must be called, for example, in the cyclically processed organization block OB1. When parameterizing the block, you can select which of the 4 possible operating modes the sequence chain should work in. For testing or commissioning, we then load the S7 project into the S7 CPU, including the now integrated S7 Graph function block. You can now monitor the sequence chain online as well as in the work area by triggering the monitoring function in the overview window. Additionally, S7 Graph offers further functions for effective process monitoring and control. The step monitoring, the so-called supervision, enables you to monitor execution times of actions, for example. In case of an error, the step remains active. However, it is not switched to the next step. The event can also be easily generated as event message or alarm message. This also applies to the so-called interlock, in which you can define locking conditions for each step. Here, all actions to be executed are only activated if the interlock conditions are true. For all automation tasks with sequential structures, S7 Graph is the optimal engineering tool. Use the benefits of this graphic programming language in order to easily realize the requirements of your automation task successfully in a time and cost-efficient manner.